In section 6.2, we're going to look at constructing antiderivatives analytically. Okay, just refresh your memory about the derivatives that we've already learned. I have a little picture here of a circle with positive cosine, negative cosine, positive sign. And if you look at this circle going clockwise, the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of negative sine is negative cosine, and the derivative of negative cosine is positive sine. And this is a cyclic pattern. If we go the opposite direction, counterclockwise, we're looking at the integral of each of those trig functions. Okay? All right, I also have listed over here the derivative of tangent is secant squared, and the derivative of secant is secant tangent. You might think about the integrals in little chunks or little families. So we have the integral of the cosine is the sine of x. The integral of sine of x is negative cosine of x. In the next two, the integral of secant squared of x is tangent x. The integral of cosecant squared of x is negative cotangent of x. The last two, the integral of secant tangent, secant of x, tangent of x, is secant x. The integral of cosecant of x, cotangent of x, is negative cosecant of x. Notice that all of the answers beginning with C, negative cosine, negative cotangent, negative cosecant. So just trying to remember your positives and negatives of the integrals. Okay, so we're going to take a look at using these trig rules for antiderivatives, and we're going to find some integrals. So the integral of 2 cosine x minus sine of x. The integral of 2 cosine x is the same as 2 times the integral of cosine of x minus the integral of sine of x. So remember, we can break this up. You don't have to, but you can. So the integral of cosine of x is sine of x. So we're going to get 2 sine of x. Integral of sine of x is negative cosine of x. That negative with the negative that's already here is going to become a positive cosine of x plus c. All right. Part B, the integral of 2 secant x tangent x. We can pull that 2 out in front as the coefficient of the integral of secant of x tangent of x, and that is 2 secant of x plus c. All right, letter C, negative 3, the integral of cosecant squared of x dx. Negative cosecant, or the integral of cosecant squared is negative cotangent. So that's negative 3 times negative cotangent. That'll become positive 3 cotangent of x plus c. Integral of cosecant cotangent is negative cosecant of x. So we're going to get negative 1/2 cosecant of x plus c. Okay, letter E, we have a product of two functions. We should rewrite this as the integral of the secant squared of x plus the integral of secant x tangent x. The integral of secant squared of x is tangent of x. The integral of secant tangent is secant of x plus c. Okay, 1 over cosecant secant x. Cosecant is a reciprocal function. It's the reciprocal of sine. So 1 over cosecant is the same as sine. So we're just looking at the integral of the sine of x, which is negative cosine of x dx. Oops, sorry, plus c. All right. The integral of 3x squared minus 5x plus sine of x. First two terms of the integrand just require the anti-power rule. So we're going to get x cubed minus 5/2 x squared minus cosine of x plus c. All right, the integral of e to the x minus sine squared of x minus 5 over x. The integral of e to the x is e to the x. The integral of negative secant squared of x is negative tangent of x. And the integral of negative 5 over x is negative 5 natural log of the absolute value of x plus c. Letter I, the integral of secant squared plus cosine squared of x. Okay, this is a trig identity. It's the first Pythagorean trig identity. Sine squared x plus cosine squared x is 1. The integral of 1 dx with respect to x is x plus c. We will do more with our trig identities. All right, but you might want to look that up and make a little table of all your trig identities. Okay, question 2, initial conditions. You can solve for a particular c value if you are given a certain preliminary piece of information. We call that information the initial condition. So in this problem, f of 1 equals 4 is the initial condition. Okay, I've been given some information. So let's find the integral of 2x plus 3. We anti-power rule this integrand, so we're going to get 2x squared divided by 2 plus 3x plus c, or x squared plus 3x plus c. So this is my f of x function. Because I know that f of 1 is 4, I can say that 1 squared plus 3 plus c must equal 4. 4 plus c is equal to 4, therefore c is equal to 0. Now my specific function is known, and f of x is x squared plus 3x plus 0. Don't really need that, but that is my c value. Find the velocity function, v of t, and the position function, s of t, corresponding to the acceleration function, a of t equals 4t plus 4, given v of 0 is 8. That's an initial condition for the velocity. And s of 0 is 12. That's an initial condition for the position function. Okay, so we know that the integral of a of t dt will equal the velocity function. So the integral of 4t plus 4 dt will be anti-power rule, so 2t squared plus 4t plus c. Using the initial condition that v of 0 is 8, we can see that 2 times 0 squared plus 4 times 0 plus c must be 8, therefore c is 8. So the specific velocity function is 2t squared plus 4t plus 8. Okay, the position function is given by the integral of the velocity function. The integral of 2t squared plus 4t plus 8 dt will be equal to 2/3 t cubed plus 2t squared plus 8t plus c. Using the initial condition that s of 0 equals 12, we can see that evaluating these terms for 0 leaves c must be 12. All right, so the specific position function is 2/3 t cubed plus 2t squared plus 8t plus 12. Okay, we have some other rules for the exponential function, and the integrals that yield the inverse sine and the inverse tangent function. Okay, so the integral of a to the x dx is a to the x times the natural log of a. The integral of 1 over the square root of 1 minus x squared is arctan of x. And the integral of 1 over 1 plus x squared dx is arctan of x plus c. Okay, so let's find some integrals here. Question A, the integral of x squared minus 3x plus 2 to the x will be 1/3 x cubed minus 3/2 x squared plus 2 to the x divided by the natural log of a plus c. Okay, our next integral, the integral of 1 over 3 to the negative x minus x cubed. Let's rewrite this 1 over 3 to the negative x as 3 to the x. Okay, the integral of 3 to the x minus x cubed will be 3 to the x divided by the natural log of 3 minus 1/4 x to the 4th plus c. Okay, question C looks like a variation on the arcsine. Okay, in fact, it's equivalent to 2 times the integral of 1 over the square root of 1 minus x squared dx. That's 2 the arcsine of x plus c. All right, question D. I'm going to rewrite question D before I take the integral as 1/2 x to the negative 2 minus 3 over 1 plus x squared. That second term did not get a rewrite at all. All right, first term we're going to use anti-power rule, so that's 1/2 x to the negative 1. We're going to divide by negative 1 or multiply by negative 1. The second term, negative 3 over 1 plus x squared, that's a variation on the arctan, just negative 3 arctan of x plus c. All right, question E, we have some rational exponents. I would leave them exactly as they are. So we're going to increase the powers by 1. That's x to the 5/3. Divided by 5/3 is the same as multiplying by 3/5. Minus 4x to the 4/5. And we're going to divide by 4/5 or multiply by 5/4. So my coefficient of negative 4 is just going to become a coefficient of negative 5. Plus 4 the natural log of x plus c. All right, question F. The integral of 2 over x plus 3e to the x is the same as 2 the natural log of absolute value of x plus 3e to the x plus c.